Hello everybody, welcome to video number 2. We're going to be starting with number 7 for cumulative review packet number 12. So if I take a look at number 7, I notice that there's two sets of parentheses, but only this second parenthesis has a power on the outside. So I'm going to focus there first. I'm going to raise the 3, the h, the I, and the j all to the second. So I get 3 to the second, h to the 3 times 2, which is 6, I to the 1 times 2, which is to the second, and then j to the negative 7 times 2, or negative 14th power. This parenthesis is just there to recognize that it's multiplication, but at this point we don't need the parenthesis anymore because there's no power on the outside. So I'm just going to rewrite it as negative 5, h to the first technically, I to the negative 5th, and then j to the 4th. So at this point, I want to start to combine like terms. First, the 3 squared is really 9. So if I looked at negative 5, we're multiplying here, so negative 5 times 9 would be negative 45. I have h to the first here and h to the 6th there. Because I see no parentheses anymore, just think about how many h's you see. I see 7 of them, which means you're adding the exponents. So you have h to the 7th power. If I look at I to the negative 5th and I to the 2nd, if I add negative 5 plus 2, I get negative 3. Then if I look at j to the 4th and j to the negative 14th, 4 plus negative 14 is negative 10. So my answer looks like I have two negative exponents, so those need to flip down. The negative 45 is not going to flip though because the number is negative, but the exponent is still a positive 1. So my final answer will be negative 45 h to the 7th over I to the 3rd, j to the 10th. Numbers 8 and 9 are much faster than 6 and 7. I'm just reminding you of a couple rules from earlier in the semester. For number 8, the 4 has an exponent currently of 1. X to the negative 7th is going to have to flip, and then y to the 0th is really just a number. We cannot combine any of these, so all we're doing is flipping and using the rules. Y to the 0th is always 1. So this is really 4x to the negative 7th times 1. So this 1 really disappears. The only thing we have to do is flip the x to the 7th down. We do not flip the 4 with it because its exponent is a positive 1. So my answer will be 4 over x to the 7th power. Number 9, I'm raising both of these to the 4th, and so I'm multiplying my exponents to get x to the negative 24th over y to the negative 12th. So, because both exponents are negative, the y has to flip up and the x has to flip down. So my final answer will be y to the 12th on the top and x to the 24th in the denominator. And I cannot subtract my exponents because my bases are not the same. Number 10, graph the following quadratic equation, then sketch the graph of the parabola using the x-intercepts, the vertex, the y-intercept, and a table if you need it. So if I would like to find my roots or my x-intercepts, this means it's on your x-axis, so y is 0. So the first thing I'm going to do is plug in 0 equals 2x squared plus 4x minus 6. And if I'd like to solve this for the roots, I could do quadratic formula, I could factor, or I could complete the square. Now, my first gut instinct is to factor if possible. So what I'm going to do is divide everything by 2 to make the problem a little easier. So you get x squared plus 2x minus 3 equals 0. Let's check first to see if this does factor. X times x is x squared. 3 times 1 is 3. To get a positive 2, I need a plus 3 and a minus 1. And let's double check the signs. 3 minus 1 is 2. Positive 3 times negative 1 is negative 3. Yeah, it factors. So now if I set both of these parentheses equal to 0, my two roots are going to be x equals negative 3 and x equals positive 1. But because roots are really intercepts, we want to write these as points, and I'll write them in this box down here. One root is negative 3, 0, and the other root is 1, 0. And so I'm going to take those and graph them here. Negative 3, 0, 1, 0. Now if I want to find my vertex next, the vertex is always in the middle of the roots. So you could find this by doing one of two things. You could either look at the graph and recognize that -1 is directly in the middle of -3 and 1, or you could find the average. You could do -3 plus 1 over 2, which would be -2 over 2, which is -1. So my vertex, I know that x equals -1. So my vertex is going to be -1 comma something, but to find that something, I need to take the -1 and plug it back into here, the original problem. So I need to plug it into y equals 2x squared plus 4x minus 6. So y equals 2 times -1 squared plus 4 times -1 minus 6, which would be, if I follow the order of operations, -1 squared first is 1 times 2 plus -4 minus 6. So that would be 2 plus -4 minus 6. 2 plus a -4 is -2, minus 6 is -8. So my vertex is -1, -8, which is here. Starting to look like a parabola. This is good news. If I wanted to find my y-intercept, this is again the best part. If you're going up and down the y-axis, x is always 0. So if I plug 0 into this original problem here, technically you would get this. So this would be 0 plus 0 minus 6. So you're just left with -6. So we write that as a point, 0, -6. And yes, you could have just looked at the equation and known it was the last number. Absolutely okay. 0, -6 is right here. So if I go back up to my picture, if I connect all those dots and make it look like a U, it looks reasonable to me. Go through the intercept, turn at the vertex, go through the y-intercept, through the other root. So look like my parabola is facing upwards because it makes sense. The lead number is positive. So that's good. The axis of symmetry, or the line that cuts the parabola directly in half, it's also called the line of symmetry, is going to be x equals -1 because all vertical lines are in the form x equals a number, and it happens to go through x equals -1 because that's where the vertex is. Is the vertex a max or a min? Well, the vertex is at the very bottom of my parabola, so it has to be a minimum. If I'm looking at my picture, my domain is going to continue. My domain, or x values, go forever from left to right. So my domain is -infinity to +infinity. My range, however, goes from bottom to top. So if I start at the bottom of my parabola, the least value that it hits here is -8. So I put a bracket on -8 because it actually could be touched. Then the parabola goes all the way up to infinity. So when you're doing range, you're going from bottom to top. So my answer would be -8 to infinity. Number 11 is asking us to do the same thing, except in this example, we may not be able to factor. So we could use a table if we'd like, but the goal is to still use the x-intercepts, vertex, and y-intercept if possible. So just like number 10, if I'd like to find the roots or the x-intercepts, that means that y equals 0. So I will say 0 equals -2x squared minus 4x plus 3. Now, I could definitely check to see if this factors first. You could do a times c, -2 times 3 to get -6. Figure out the pairs that multiply to be 6 are only 1 and 6, 2 and 3, neither of which gets me 4. So no, this doesn't factor. And I also would avoid completing the square, because if I divide by 2, that makes everything harder. So it seems like good old quadratic formula is going to be the winner here. And so if I'd like to solve this, let's use the quadratic formula. X equals -b plus or minus the square root b squared minus 4ac all over 2a. So x would be -4 plus or minus the square root of -4 squared minus 4 times a times c all over 2 times -2. So we have x equals +4 plus or minus the square root. -4 squared is 16. Just like another problem earlier, I see two negatives, which means I have a plus. 4 times 2 is 8 times 3 is 24, all over -4. If I bring this up here, I have x equals 4 plus or minus the square root of 16 plus 24, which is 40, all over negative 4. So at this point, as we talked about in class, you could absolutely take the 40 and split it into 4 and 10 and continue simplifying. However, because we're graphing, it would make more sense here to find my two decimal answers. And to find those, you'd plug 4 plus root 40 divided by negative 4, and then 4 minus root 40 divided by negative 4. Now, if you do that, if you take 4 plus the square root of 40, press enter, and then divide by negative 4, you would get negative 2.58 here. If you do 4 minus the square root of 40, press enter, then divide by negative 4, your answer would be 0.58. So as of now, my two roots are in the format negative 2.58, comma 0, and 0.58, comma 0. And so if I did the best of my ability to graph those two, 0.58 is right in between 0 and 1 about, so one of the dots would be right about there. And negative 2.58 is about negative 2.5, so it would be right about here. So if I'd like to find the vertex, this is when knowing the idea of an average is a lot more helpful rather than counting on your graph. If I know these are my two roots, I know my vertex has to be in the middle of them. So if I took negative 2.58, found the average, plus 0.58 and divided that by 2, if I added negative 2.58 plus 0.58, I get negative 2, and if I divide that by 2, I get negative 1. Now, it is a coincidence, by the way, that for both examples on this packet, my vertex is negative 1. You absolutely could have another number here, and there's more examples in class that we're going to be doing to make sure you know that. So in this case, my vertex so far is negative 1 comma a number. But again, to find the y value, I need to take the negative 1 and plug it in here into y equals negative 2x squared minus 4x plus 3. So if I plug in the negative 1, this is similar to if you had done a table. You'd have to do this idea multiple times, which is definitely tedious. Y equals, so negative 1 squared first is 1 times negative 2. Here I have two negatives, so it's plus 4 plus 3. So we'd have negative 2 plus 4 plus 3, which is 2 plus 3, or 5. So my vertex is at negative 1, 5, which if I graph it, would be right here. And I thought I'd point out, at the beginning of the problem, I noticed that I have a negative in front, which means my parabola should be facing upside down. So I sure hope it looks like that. The y-intercept, you plug 0, x equals 0, into the original equation. So this time I'll save a little time. If you plug 0 into this here, these two terms cross out, so you're just left with 3. So your y-intercept would be 0, 3, graphed here. Looks reasonable for my parabola. So my parabola is going to be facing upside down, turning here at the vertex, and going through all my different intercepts and roots. So it's going to look something like that. My vertex this time would have to be a maximum value, because it's at the top of the graph. My axis of symmetry is going to be x equals negative 1, because, again, it's the vertical line that cuts the parabola in half that hits the x-axis right there. My domain of this would, just like the last example, be negative infinity to positive infinity. The range, though, would be different than last time, because we're going bottom to top. This parabola, again, starts down here at negative infinity, which is different than the last example. Then the highest value that this parabola hits is up here at 5. So my range would be from negative infinity up to 5 with a bracket. All right, guys, that's where we're going to end on this video. We're going to start the next one with number 12. Thanks.